Okay, so example 3, we're going to continue to use our exponent properties to solve equations. In the last example, it worked out really nicely because we had the same base on both sides of our equation. So what do you do if you don't have the same base? We have a 27 over here and a 3 over here. So I don't have the same base. I can't just set the equation or the exponents equal to each other. Well, the beauty of mathematics is we can manipulate it, and we can often get it to look the way we want to make it a little bit easier. So this 27, what we're going to do is we can rewrite that with a base of 3, because 3 to the third power is equal to 27. So we're going to take that 27 and we're going to replace it with 3 to the third power. That's the same thing as the 27. I'm going to carry down the exponent, x minus 4 equals 3 to the 2x minus 6. So we're getting closer. We've got our base of 3's, but we do have to simplify this side over here a little bit. When we have a power raised to a power, we are going to multiply these exponents together. So we're going to take this 3 and multiply it by the x and by that negative 4. So we have 3 to the 3 times x and 3 times negative 4, so minus 12, is equal to 3 to the 2x minus 6. Okay, well, we just did some beautiful manipulation. Now we've got the same base equal to each other, which means that your exponents, whatever they are, will be equal to each other as well. So we can say 3x minus 12 equals 2x minus 6, and then just do some solving. Let's subtract 2x from both sides. 3x minus 2x is x, minus 12 equals, I'm going to carry down that as a negative 6, and then we will add 12 to both sides, and we get x equal to negative 6 plus 12 is positive 6. Okay, so again, we had an equation where we didn't have the same base. We were able to manipulate it to get the same base, which allowed us to solve our equation. So guess what? We're going to do the same thing over here. We have an equation with, here's a base with an exponent, a base with an exponent. Are the bases the same? They are not. So let's focus on the bigger exponent. Can we rewrite 256 as a power of 4? And if we think through, 4 to the first power is 4, 4 to the second power is 16. If we go through our powers of 4, we end up with 4 to the fourth power being equal to 256. So what we're going to do is we are going to replace the 256 with 4 to the fourth power. I'm going to carry down that exponent of x plus 2. It's equal to 4 to the 3x plus 9 over here. And now we have a little simplifying to do over here. We will multiply that 4 times the other exponent. So we have 4 to the 4x plus 8 equals 4 to the 3x plus 9. A little bit of mathematical manipulation goes a long way. Now we have the same base. If the bases are equal to each other, that means the exponents will be equal to each other. So we will just grab this exponent, we will set it equal to this exponent, and that's an equation we can solve. 4x plus 8 equals 3x plus 9. Let's get the x's to the same side first. We will subtract 3x from both sides. 4x minus 3x is x. Carry down your plus 8 equals 9. Last step, we will subtract 8 from both sides, and we get x equals positive 1.